Hey everyone, CocoaButterCoder here, aka Coco, and welcome back to another episode of Cipher Saturday. If you know, Cipher Saturday is when I take a cipher from the code book by Simon Singh and I try to code it in Python. This is only the second episode, so either thanks for coming back or welcome. I tried to get this up earlier. I usually like to get my videos done either like the night before, the morning of, but I was having some microphone issues when I upgraded Ubuntu, so I'm doing it now. It's a little later than I wanted, but hopefully it's still good regardless. So today we're going to be working on a cipher that, to my knowledge, doesn't have a name, but in the book it's called I'm calling it the Kama Sutra cipher. So this is an excerpt from the code book by Simon Singh. Again, if you haven't read it and you're interested in like cryptography or codes and ciphers type stuff, I would recommend it. I've read it when I was younger. I'm rereading it now, and it's still just as good, even though it is like 20 years old at this point. But this part, is talking about one of the earliest descriptions of encryption, and it says that it was in the Kama Sutra, right? So we all probably know the Kama Sutra for one thing in particular, but it turns out there's all this other interesting stuff in there that I wasn't aware of. So it says that women should study 64 arts such as cooking, dressing, massage, and the preparation of perfumes. Um, you can get into whether or not you believe in or agree with that sort of thing. But it also says it lists some less obvious arts, namely conjuring, chess, bookbinding, and carpentry. And then number 45 on the list is, and excuse me if I most likely mispronounce this, but Malekita Vikalpa, the art of secret writing, advocated in order to help women conceal the details of their liaisons. So technically this isn't even supposed to be the next video. The cipher before this is about the side tail. I don't know what it was about it. Just like, I think it's kind of cool. I think all of this historical cryptography is honestly really cool, just because at the time it was like these were considered the pinnacle of communication strength, and now they're kind of like, this is still like chapter one type stuff. Like, oh yeah, we've since broken them. We since found all their weaknesses. But it's still kind of cool to see how creative a lot of these ciphers were. And the fact that they were used for such important like diplomatic or political or military type things. But something about the Sightail, it just seemed, I don't know, kind of a hassle to try to code up. Um, I might still do it. I started looking up other YouTube videos about Sightails, not necessarily anyone doing it in Python, which it makes me want to do it even more since it hasn't been done. So I might come back to this one. But for right now, we're just going to skip it and we're going to go to the Kama Sutra cipher. So it says that one of the recommended techniques, so I mean, maybe there are other ways to do this, but it says one of the recommended techniques is to pair letters of the alphabet at random and then substitute each letter in the original message for its partner. So for example, in this image here, it has this like example cipher key where you have A mapping to V and then V mapping to A, D mapping to X, and X mapping to D, H to B, and B to H, and so on. So in our English alphabet, with 26 letters, you're going to have 13 pairs. And so we can kind of get into the code, but before we do, I just wanted to show one comparison in the notebook.
So this time I actually wrote it out ahead of time so you guys don't have to watch me like slowly write everything out. And now it's a little bit easier to read. But what I wanted to draw a comparison to is this seems very similar to like a ROT 13 cipher to me. So if you're not familiar, ROT 13 is short for rotate 13. And it's a type of Caesar shift cipher. And so there are 25 unique Caesar shift ciphers. You can rotate one space, two spaces, three spaces, all the way to 25. And I say unique because you could rotate like 27 spaces, but that's the same as rotating 26, which is not rotating at all, and then rotating one more. So there are only 25 unique ones. Rat 13 is interesting because we have 26 letters in the English alphabet. If you rotate a letter or if you shift a letter 13 spaces, so A goes to N. If you then shift that new letter 13 spaces, so N goes to A, it loops back. And if we, right here, I just kind of wrote it how they wrote it in the book. I just wrote it how they wrote it in the book of A goes to N, and then N goes back to A, B goes to O, O goes to B, C goes to P, P goes to C. So it just seemed like it has some similarities to the Rot 13 or like a XOR type cipher, where you only need one cipher key. So yeah, this one cipher key can be used for encryption or decryption. That's why here in the code book it says that the convention is that plain text is written as lowercase and ciphertext is written as uppercase. But here it's like plain text and ciphertext are interchangeable in a way. Not, well, maybe interchangeable isn't the right word, but just the fact that like because you can just use the same cipher key twice to go back to where you need to be, I just wrote it all as lowercase. So now we can go back and get into the coding.
Okay, so now that we're back at the computer, we can open our code. So I have this empty file called Sutra YouTube.py. I usually, this file here, I usually do like one run through of the code beforehand, just so I can work out any kinks, make sure that I have a solid understanding of how I want to do it. And then during the videos, I try to do it from scratch just to show my thought process and everything. So the main thing from the book is that it says it pairs letters at random. So we're gonna start with I'm gonna start with our usual user prompt of encryption or decryption. So would you like to encrypt or decrypt? Now this is kind of strange because in this cipher, like, because there's only the one cipher key, technically you wouldn't need to ask. Someone could just provide a message and you could run it, and like to them it's either the ciphertext or the plain text, and it would pop out the correct I guess the correct complement without having to prompt them. The only reason I'm adding this is because for encryption, because the book says to start just pairing letters at random, in my head it kind of makes sense of like, if you have two people and you need to encrypt a message, first you have to decide on what the dictionary is, and then encrypt, and then the person who's decrypting would already have that dictionary and they can decrypt. So what we're going to do is that the person encrypting, that method is going to generate a random cipher key, and the person decrypting, if they choose that option, they have to input the cipher key in order to decrypt the message, and that's really the only difference. So we're going to ask encrypt or decrypt, and then process is going to be equal to whatever they input, and then just lower it just in case. So if process equals encrypt, then we're going to, what do we need? We need to generate a cipher key. So cipher key is going to be equal to generate cipher key. And then we need to ask what the message is. So print, what is the plain text? Then plain text is going to be equal to input dot lower. And then now we can have our ciphertext equal to encrypt. can pass it the plain text and the cipher key. Okay. So let's just flesh this out before we even do our decrypt side. So we're gonna start with the generate cipher key. So I'm gonna just do alphabet equals string dot, and I need to import string. So this is something that I found, and let me pull this back up. It says that string is a collection of string constants. This is something I found in, what was it? Probably my Python challenge video for the make trans. So quick tangent, if you're not familiar, Python challenge is like a website with all of these Python like challenges, and each one that you solve leads to the next one. And so one of the videos, it's like a Caesar shift of 2, and I'll link that video in the description, or just the Python challenge playlist that I've made. But in order to solve it, one solution I saw was using this collection of this collection of string constants called string, instead of typing out all the letters of the alphabet. So I'm just going to do that here, just because I want to. So string dot ASCII letters lowercase. And the reason I'm going to do this is I'm going to make this, I should actually just make this a list now. So this currently is a string. If I do this, list, now it should be a list. So what I can do is also import random and do, just to show how this works, print alphabet and then random dot shuffle alphabet. Then we can print alphabet again just to see what's in it. And then get rid of all of this so it doesn't throw an error. I can just run it here. Okay, so we want to encrypt. So what this code up here does, string ASCII dot lowercase is just one single string of the letters A through Z, and then random shuffle is this method which just shuffles just items. The thing is that shuffle needs to take in a list, and even though like strings are list-like in a way, they're not lists. So we have to use this list method in order to change this string into a list, and that's why we get all of the letters just pieced together. Like I said, we don't even have to import string. I could have just typed it all out. I just didn't feel like it. But this printing of the alphabet gets us this here, and then if we shuffle the alphabet, we don't have to, it doesn't return anything. It says that it shuffles in place. So now alphabet looks like this, all shuffled up. Then what I'm going to do, so I can get rid of this line, don't need that, and this line. So I need, as well as the alphabet, I need our cipher key. And that's just going to be an empty dictionary. And then what I'm going to do is maybe I'll just organize it like this. Okay, for what do I want? I guess index. Yeah, for index in range of length, start at 0, length of alphabet, and then we'll step by 2. We want to, inside of our cipher key, we're going to do cipher key at alphabet at index. It's going to be equal to alphabet at index plus 1. And then we'll just print it to see what that gets us. So encrypt. Okay, cool. So we should have, and what's the length of this? This should have a length of 13. Cool. So these two are not necessarily the same dictionary, but here you can see K maps to U, L to C, Q to Y, and then it has 13 pairs, which is what we want, every letter paired up to another one. So now that we have our cipher key, we can get rid of this print line here. Then we need to uncomment all of this, and then we can work on our encryption method. So I'm going to do that right now. So we're going to do def encrypt and pass it our plain text and our cipher key. So we need a cipher text variable, and that's just going to be empty. And now we can do for character. Well, here's a problem, right? So some of these letters are going to be keys and some of them are going to be values. So what we can do is, instead, I think we have to do for key value and cipher key dot items. If cipher key oh wait, I need to return cipher key. Okay, there are functions, but if cipher key dot get So I guess one way of doing this is, if cipher key is in the key, then return the value, and then if it's in the value, return the key. So I guess the way I want to do that is, if cipher key let's do it like this, for character in plain text, if character is in the cipher key. So if using just the cipher key itself is the same thing as saying if it's in cipher key dot keys. So you can just do that for completeness sake. If it's in the keys, and then we'll do some. Oops, can't do that in Python. We'll do some stuff. Then else if character in cipher key dot values, we'll also do some stuff. So the stuff that we want to do, if it's in the key, we can just return the value. So we can just do stuff here. We could just do ciphertext plus equals cipher key dot get character. Now the tricky part is going to be for the values. I'm pretty sure the way I did it before was that it's ciphertext or ciphertext plus equals. I think you have to get the index. So we can do cipher cipher key dot what I want to do. I think the problem was that because dictionaries don't have indexes, it's just all like random. You have to do it in a special sort of way. Yeah, so we'll scratch this. We'll keep it for reference sake, but instead we're going to do for key value in cipher key dot items. If character is equal to the key, then we're going to do this ciphertext ciphertext plus equals cipher key dot get character. Yeah, that's fine. And then else if character is equal to the value. Honestly, I don't even think you need to do this. You can just do value. So then we do ciphertext plus equals key. Okay. So I'm just going to do this if character is alpha, then do all of this. Else just do ciphertext plus equal the character. Okay, now we can get rid of all of this. We have to return the ciphertext. And I'm just going to print the key. So we can do print the cipher key is, and then just do cipher key. Now we can kind of check against it to make sure that like it lines up to what we want it to be. So we'll do encrypt, then only concatenate. Okay, that makes sense. Cipher key dot, don't think there's like a string method. There is a string method, but just not in dictionaries. So let's see what happens if we pass it through the string method. I don't think this is what I want. Oh, it is. Okay, so this is our cipher key. And then, what was it? The plain text can be meet at noon. And what happened? We passed it the plain text. Plain text goes in, and it returns because this is still in the for loop. Yeah, it should be here. Okay, so encrypt gives us our cipher key, meet at noon. and it's still not. Oh wait, I haven't printed it out. Okay, so print the cipher text is, then ciphertext. Okay, now let's try it. Encrypt, and then meet at noon. Okay, so M goes to B, and then what does E go to? E goes to W, E goes to W, and then T goes to G. Wait, oh wait, where is it? T goes to K. Okay, excuse me. So it looks like it does work. Now we can work on the decrypt. So we can do aleph process equals decrypt. And then prompt the user just to input their cipher key, so we can do it. Yeah, so please input the cipher key. And I guess we can do it like this, e.g. I don't know, PB, JK, WQ. I'm just gonna do this on a new line. For P to B, J, K, W, Q, etc. So hopefully that's enough of a good enough of an explanation. So we can do cipher key equals input. Just lower it. And then what we need to do is then generate the actual cipher key. Can I reuse this? Let's see if I can reuse this. This takes a random alphabet and then shuffles it. So this is like the main part that's actually useful in both scenarios. So what we can do, that should be so here we're gonna type in key string. Yeah, this should work. Okay, I'm just gonna move this because this doesn't actually need to be in the actual generate cipher key. So we can do in our encrypt, pass it this random blob of mixed up letters, shuffle it, and then pass the alphabet into our generate cipher key. And in here, pass cipher. This is actually a list. I guess it doesn't matter. This is going to be a string, while this is going to be a list. So it's like kind of a toss up. So I'll just keep this as a string. Then maybe join all of this together. So alphabet. So we're just gonna do dot join alphabet. This join return. I think it might. So we're gonna do alphabet just in case equals all of that joined together. Pass it the alphabet. Now it's a string. Yep, this is a string now. Now we have our key string. And then here, wanna replace, no, not all of them though. This one. All of those go to key string. And I think it should work. Let's run it to make sure. Let's do encrypt. We get our keys still jumbled up. Then we can do meet at noon. M goes to D. There's R goes to E, R goes to E, then O to T, O to T. Okay, so it should still work. Yeah, it's looking like it's working. Okay. So have our cipher key here. Then we can pass this. Let's do it again. Cipher key is going to be equal to generate cipher key of cipher key. We don't need this print line because they already know because they inputted it. And then we can do print. What is the cipher text? And then cipher, and then we'll do plain text equals decrypt cipher text, and we need our cipher key. And then just to make sure we don't forget to print it out like last time. Nope, just this line. Print this and change these two. Let's copy this first. Change this to plain text. Okay, then we go, don't actually need, here we have, I guess we can kind of make this generalizable. So in Cipher, I'm gonna change this encrypt to just like a more generalizable translate. This is gonna be message. Plain text is gonna be message. So actually, let me do this now. So this, I think that's the only place I have plain text. So both of these are gonna be message. The cipher text. This is going to be message complement, character message, character is alpha, yada yada yada, message complement. Okay, so now we can actually reuse this translate for our cipher as well without having to change anything. So this can go to translate, and this can go to translate as well. Okay. I think that should work. Okay, let's try it out. So let's do encrypt. And then we'll do meet at noon. And then we'll check it. So let's find our M goes to A. Where does E go? E goes to Y, E goes to Y, and then K to T, is that right? T goes to K. Yep. Okay. So now we're gonna run it again. We're gonna choose decrypt this time. And then we're gonna list it out. So ONIFDPRXEYVJUBSQCTKGLMA. And what does it say? Ciphertext is not defined. Where is that? That's on line 52. Line 52. Ciphertext equals input dot lower. Okay, we can try running that again. So encrypt. Let's just assume that it works, so we don't have to go through it again. And then we can run it again, decrypt, and then we'll do LEVBBKNDTAXCWGYIHZOFPMSR. Then we need our ciphertext. So PLODXDKFFK. We need it new. And so I think that's about it. That's all we need to do. There are obviously some things like usually when I do these videos, there's a lot of stuff that I like that I omit. Like I could probably put all of this into a while loop, so that people can input as many messages as they want. That does come with the hurdle of like this encrypt would probably have to change slightly of letting a person either randomize a cipher key or input one, because if you're inputting the same messages more than once, maybe you want to use the same key. So yeah, using while key, probably checking to make sure like our cipher key is 26 letters long, all alpha and not like alphanumeric or have like weird symbols in it. And other than that, I think that's it. Just want to thank you again if you're watching and you're interested in this kind of stuff. It's been awesome having people like watch my videos and comment on Reddit and stuff like that. It's not my intention to get big. I always say this, but like I'm just doing what's fun for me right now. So it's kind of cool to have people join me on the ride. And speaking of fun, last thing I wanted to say, so I found, where is it? So I've been kind of getting into like ARGs recently. I think it's all hand in hand, like watching, Cicada 3301 breakdown videos, and being familiar with different ARGs before, like, the Cloverfield one or the Mr. Robot one, and finally feeling comfortable enough in like my technical and programming skills to feel like I can contribute. So I've been trying to find, especially when I found the Python challenge, that's really what like was the accelerant or the catalyst for me being like really interested in this sort of stuff. And so in the process, I found this website called Game Detectives. It's really cool. It's like it's a whole community that gives you both the tools necessary to solve ARGs. Not all of them, they can get kind of complex, but there's stuff like this academy, which just goes over some preliminary stuff. A lot of it I already knew. Some stuff like audio or steganography stuff I hadn't worked with before, so that was really cool. But there's a Discord and a subreddit, and super helpful group of people in both. Super embracing and accepting. It just seems like a cool environment just in general. So if you're interested in like ARGs, or just like puzzle solving, cryptography, ciphers, and codes, I would recommend it. And I think that's all I have. I think in the same vein, there is like something similar to the Python challenge called AE27FF, which I might start doing videos on just because it's just a fun thing. They probably won't be like one video each, like the Python challenge, because they don't seem, even though apparently it was based on the Python challenge, they don't actually require much Python. Maybe I'll try to do like 10-minute videos or something for those. But just stay tuned. And thanks again. Have a nice rest of the weekend.